They are monstrously common. And this is due to the incredible diversity of their diet and habitats in which they can survive. So for example, they cover the bottom of the ocean, we'd find them in soils, and then more than 50% are parasitic. We find them in trees, feeding on the roots of our crops, in the guts of animals, and even indeed in humans, where you get the horrible species that can occupy the eyeball of a child. It's a really interesting creature. And so what I'm looking at specifically is parasitic nematodes, which follow the life cycle based around animals. And they'll sit in the abomasum, which is a part of the digestive tract, reproducing away. Eggs pass out into the feces, and where they develop slowly through the larval stages based on environmental factors, which is what's so critical and is what I'm looking at. So for example, eggs hatch at a certain temperature threshold, which is met at a certain point of year, typically which is most ideal for them. So for example, there's a species that will only hatch between 11 and 18 degrees Celsius. Likewise, the larvae are most typically limited by water. So for example, water, film or dew is needed for the larvae to move from the soil or the feces in which they hatched onto the pasture to be eaten up again. In temperate countries such as this one, that isn't a problem, because as we know, it absolutely drops it down with rain most of the time. But out in the desert, for the Saiga, it's much more rare. So the transmission of parasites is entirely limited to rainfall, and we can track that. And that is where climate change comes in. So what we have here is a map of Kazakhstan, the country, and overlaid is each individual cell, a temperature average over a period of 10 years. So if we start in 1979 to 88, we can go forwards in time into the 90s, into the noughties, and to the present day. And if you go through that quickly, you'll see just how much it's changed over time. We're talking a degree or two of change, which is absolutely massive in terms of climate change, and it is one of the world's leading climate change hotspots, which is really something. So the consequences that that has is huge. For example, if we've got this species that is reliant on an 11 to 18 degrees Celsius window, suddenly we're seeing that come much earlier in the year. So you see egg hatch that might suddenly be misaligned with, say, a migration route. And organisms that were left in one place the year before, if their eggs are sitting there, the Saiga haven't made it that far north yet, and the temperature up again this year, suddenly you've got a hatching, but there's nothing to eat them. So everything dies, and suddenly we have a massive population deficit. Those are the kind of questions that we need to be considering. And to track this, which was my research, is this absolutely huge mathematical model. And don't worry, it still gives me a panic attack every time I look at it, so I won't go into too much detail. But in short, the little green section just there is effectively what that little circular diagram was before. You input eggs into the system, and then with a little bit of mathematics, you track it through the life cycle and remove individuals based on mortality rate. So for example, under climate change we'd expect more extreme temperatures, so during the summertime peaks in mortality would mean that we get 0. So this, I think this is in January 1979? Yeah, so we're getting no larvae come out because it's far too cold for them to develop. That's the point of my work. However, it's all good and saying we have this theoretical model, but it means nothing if we can't test it. So what we have to do to test it is go out there and see what's going on in the population, and that's exactly what I got to do earlier this year in the month of May. So hopping into a van and this little Russian military tabletka from the 80s, which was an absolute pleasure to drive around in. Yeah, it's really good fun. The inside of these flowery seats pointing towards each other is a really bizarre experience. Imagine going along that with 4 or 5 Russians that barely speak a word of English, have a shot of vodka every half an hour or so, just to keep things lively. That was the kind of trip that it was on. But we're following radio collars and traditional tracking methods, such as footprints in the dirt, until we get to a point where we find the Saiga. And oof, yeah, it's really not easy to see. I didn't get any close-up pictures because of how busy I was. But if you see these tiny little specks on the horizon, those little dots of brown, each one of those is an individual animal. So what we're looking at there is a population of about 5,000 animals. And the sound, when you get this close to them, it's overwhelming. It's like being at a concert, or when you go to Wales and there's a field of particularly noisy sheep, but multiplied by 1,000 times. And what I came to be known as while I was there was the poo scientist, because that is my job. How you best determine what exactly is going on in a parasitic population is examine the fecal matter, because that's where the eggs are. So I would go around, pick up Saiga poo, and I'd sit there with my microscope out in the desert for hours on end, looking for eggs, counting them, and then running the maths, and you come up with an estimation of just exactly what species are where. And equally important is finding dead carcasses, because that means you have an opportunity to open them up, grab out the adult worms inside, because often some of them aren't reproducing at a particular time of year, and it's a much more representative, albeit rarer, way of seeing exactly which parasites are alive in the area. And so it was really possible to get hands-on, and you can see me there having a whale of a time getting in there with the dissection. And just those 4 tubes on the left are what I had to show for it at the end. So you see there just the kind of size that they were. These are 1mm tubes, so maybe that sort of height, and then there's these tiny fraction of a millimetre worms sitting there in the bottom. Brought those back to the UK, and we can image them under a microscope to see exactly what they look like. So the 2 images on the left is the exact same organism, just magnified a few times. And then on the right-hand side, we have an entirely different species at the same magnification as that one. And you can see what you'd think were just little white specks actually have a huge amount of diversity when you put them under a microscope. And that's exactly what we use to understand what species are where. So why do we care? What's the significance of all this? We're sure we can help track a parasitic population in a foreign country, pick it into the future, or to save some antelopes with some floppy noses. And you think, okay, why are we wasting all the money on that? It's just an antelope with a floppy nose. But in actuality, I don't know if we have any farmers in the room, or people that have worked with livestock in the past. Not at all? Well, it's actually hugely important in the United Kingdom in general. We actually have the same, at least genuses of parasites here that you would get in Kazakhstan. And it's a huge issue. Farmers have to spend thousands and thousands and thousands of pounds a year in order to keep their livestock safe. Now, on the right-hand side, we've got some examples of temperature scenarios used to calculate parasite burden in the future in the exact same way that I mentioned in that Excel document earlier. And you'll see the changes that we're looking at least, well, 80 years down the line, but often even sooner under more extreme climate scenarios, are really quite severe. So particularly in the north during the summer period, we're getting far more explosions of parasites than we had in the past. But equally in the southwest, we're predicted to lose a bit of parasite intensity. And this is because of intense drought. As I mentioned, parasites have a hard time making their way to pasture in the absence of moisture. So we see in the southwest, more drought actually has interesting consequences in perhaps making it easier to raise livestock in that area, assuming, there's obviously other challenges with pasture. But it's really quite complex. And then in December, where at the present day we see little to no parasite transmission at all of a sudden we've opened up this opportunity where normally the sheep don't have to worry about fighting off these things with their immune system. Now we're getting transmission coming in during the winter months, and that will have significant consequences for our agriculture in the UK, agriculture worldwide, and indeed in conserving endangered species, as I was trying to do. So climate change is going to have massive impacts on organisms worldwide, all because of these tiny little white worms that you can barely see without a microscope. So that's my research. I hope that's interesting to you. I'm happy to take questions.
Presumably the worms aren't benign, they're harmful to the animal, are they?
Yes, they're harmful, and it varies in their degrees of harmfulness. So, for example, there's 3 key species that I study. The 2 of them just sit there in the gut and absorb nutrients, so still quite harmful because the animal has to eat more. But the 3rd one actively burrows into the intestinal lining and feeds on the blood of the organism and the tissue fluid, really causes harm to it, especially if any eggs make their way into the bloodstream as well and can insist on other parts of the body. Starts to cause real issues.
Following from that, excuse me, I had an infestation of leather jackets in the lawn.
Really?
I was told about nematode
Yeah.
to attack the gloves. Would that have been harmful for the dog?
I can't say so much.
No, okay.
I'm knowledgeable about that species in particular, but often nematode worms, they have specific hosts. So I'd have to Google it to tell you in short. However, it's most likely that it won't be a generalist, and it'll have gotten there through something else, or it could just be free living.
The dog's still alive, anyways.
The dog's still fine, and yeah, most animals can handle quite a significant parasite burden without worry. So even if it is a problem, it should be fine. But if you do have any concerns, I'd take it to the vet if I were you, just in case.
What about most humans?
In the UK, not so much a problem because thanks to our healthcare, we've dealt with all of the bad stuff. You really need to worry if you're out in somewhere like Central Asia, Indonesia, or in Sub-Saharan Africa. Anywhere where there's enough moisture for them to survive, And if, say, your food's being handled without proper sanitation, there's going to be eggs on that food, and you're going to be putting them in your body. And for the most part, it's fine. We get thousands, people often go to these exotic places, they come back with roundworm infection, and then you just, a couple of tablets, it kills them all. You have a really dodgy poo for a couple of days, full of these gross white things, but then it's done with, and you're fine. But obviously, in a couple of cases, it can cause severe health issues. So raising awareness about them like this is a good way to make people know it's dangerous.
How exactly did they die so quickly? Where did it attack?
So it entered the bloodstream. The parasite, I can't remember the exact details of the anatomy, but it sits in a little gland just in the throat area normally. And the leading theory right now is from somebody at Royal Veterinary College that suggests it was a product of the humidity at that leading time, which just caused the bacteria to change their behaviour, as organisms can do. And it got through the blood barrier, entered into the bloodstream, just reproduced and was putting out toxins to the point where it literally just kills them in the space of hours. They just get so overwhelmed, and because it's such a recent disease, the immune system's just not there for it.
If this nematode, particularly, can almost wipe out the species, won't they wipe the cells out if they've got nobody to carry on through the life cycle?
You've just summarised the exact sort of problem that parasites and indeed any disease faces, is you're constantly under evolutionary pressure to be virulent and to gain everything you can from your host, but also at the same time, any organisms that do kill their host before they reproduce will not be able to reproduce themselves. So going forwards in evolution, if you like, the DNA that's passed on is selected for animals to reduce their harmfulness so as to get the most they can from the host, or ensuring they're alive for as long as possible to reproduce for as long as possible. So Pasturella is a rare case, but nematode, you don't get many massively different nematodes because they're well evolved to exploit their hosts for as long as possible, as opposed to killing them.
Interesting. Is there another theory for the right hand of the dinosaurs?
You know, with the dinosaurs, anything is possible. Honestly, it was probably
You can't Google that either.
No, you can't. No. The dinosaurs, it was probably 1,000 factors stacked on top of each other that just led to it. You know, it's possible. Nematodes being the most ubiquitous organism on the planet, I'm sure the dinosaurs struggled with nematodes as well. Was it the thing that polished them off in the end? Unlikely, but hey, great suggestion. I like your thinking. That's good stuff. Cool. Is that everyone? Elisa?
Oh, you're particularly interested in parasitology, which is all one month. You're going to carry on.
Yeah, so when I was at Sheffield, there was a particularly inspiring professor called Duncan Cameron that led our symbiosis module. My entire time there, that's the most engaging I've found course material. And then that led me to my current MSc supervisor, whose work was on nematode worms in Kazakhstan. And while it's certainly a passion of mine, I'm not sure if I'll continue it into the future, but that's more to do with the struggles in research with the current research climate in the UK. So it's not as if I'm losing my interest in parasites, it's more I think there's more I can do for conservation in other avenues than research, which is what I'm